Hi folks, welcome back to Math with Captain Rod. The purpose of this video is to talk theoretically about how to find the extreme values of a function. And I'm going to, for this example, restrict it over to an interval a to b. So extreme values mean, the highest and lowest points on the function, or highest and lowest points on the graph of a function. So in the example that I have drawn, I'm going to go ahead and show where the extreme values are, right? Right there is the highest point on this graph, or I'm sorry, the lowest point on this graph. Because that point is the lowest point on the graph, that's what's called an absolute minimum, lowest possible point on the graph. That's a little different than this point right here. This point is an interesting point, and you notice that that point, it's lower than these two regions around it. It's lower than here and here. That point's called a relative minimum. This one is called an absolute minimum because it's the absolute lowest on the graph. This one's called a relative minimum because it's lower than the 2 points on either side of it. If I looked at this point right here, that point's called a relative maximum. This point right here is also a relative maximum. So you have two types of extreme values. You have relative extreme values and absolute extreme values. The relative extreme values are points like here, here, and here, where they're extreme relative to their neighbors next door. Meaning that like this point's a little higher than here, a little higher than here. This point's a little lower than here, a little lower than here. This point, a little higher than here, a little higher than here. Then you have absolute extreme values. Those are the lowest and highest points on the graph. In this example I've drawn, this point right here is the absolute minimum. Now, you'll notice that this point's an end point, and that's okay. The absolute maximum, I'm going to have to get my straight edge to kind of tell, is, oh gee, I made those just about the same. It's the higher of these two. It looks like it's the higher of these 2 points. I happen to just freehand it and drew them so darn close. I'm going to just assume, it looks like this one maybe is a little higher. So this one right here, I'm going to call the absolute maximum on the graph. So a relative extreme value can be an absolute max or min as well. So there's two different types of extreme values, relative extreme, max, and then there's absolute extremes. As far as finding the relative extremes, there's a very important property at those relative extremes. Again, let me put this line here back to this relative minimum. And notice if I draw the tangent line in green, it would look like something like this. Also notice up here, if I draw tangent lines at the other two relative extremes, what you'll notice, what they all have in common, slope of the tangent line is 0. We can use this to find relative extreme values. Okay, relative extreme values are found by setting y prime equal to 0 and solving for x. Now, just because a y prime is equal to 0, that doesn't actually guarantee an extreme value. Sometimes what can happen is a function can come kind of like this, have a 0, and then back up again, in which case this would not be a relative extreme value. That does happen, but the overwhelming majority of the time what happens is when you set y prime equal to 0, solve for x, you find an extreme value. Now, a relative extreme value. You notice there's two types though. You have what are called relative maximums here and relative minimums. You also want to be able to know when you find a value for x and its corresponding y value, which one you have. If you have the graph, it's usually fairly obvious by looking at it, by inspection. If you don't have the graph, you can tell by the second derivative. If you take a look at what's happening right here, and again, look at the tangent line slopes. The tangent line slope just before is some positive value. The tangent line slope just after is some negative value. Oops, where's that? There we go, looking something like maybe this. So in cases like this, When your slope is decreasing, that means that the second derivative is negative, because the second derivative tells you what the first derivative is doing. When your second derivative is negative, your slope is decreasing. When your second derivative is positive, your slope is increasing. So an example would be this guy right here, where our slope goes from negative to 0 to positive. Right? So let me kind of see if I can kind of summarize this all up here. To find relative extreme values, you set your first derivative equal to 0, solve for x. You typically then check it against the second derivative. Oops. If your second derivative is negative, that means you're looking at something like this, where the slope is decreasing, and what you have found is a relative maximum. If your second derivative is positive, you've got a case where the slope is increasing. That's like here, where the slope goes from negative to 0 to positive, and you have found a relative minimum. And if your second derivative ends up equaling 0, it's not an extreme value. And the example of that, what that looks like, is the example I had before, where the function maybe does something like this. And the function changes concavity. So you find relative extremas by setting the first derivative equal to 0, solve for x. Then you tell whether you have a relative min or max by looking at the second derivative. Second derivative negative means relative max. Second derivative positive means relative min. Second derivative 0 means the value you found in the first part is not an extreme value. Now, this will tell you the relative extreme values. When you're looking for absolute extreme values, what you do is you check the values of these relative extremas, and you also check your endpoints. The largest of all of those values is your absolute maximum, and it may or may not be one of the relative extremas. The lowest of all of those values is your absolute minimum, and it may or may not be a relative minimum. In this example, this point here, I'm going to do this in red actually. Try that again. In red, that point right there is the absolute minimum on that graph, and it is not a relative extreme value. The intention here, the way I drew this, was for one of these. I think this one's just slightly higher. That point, assuming that's just a little higher than this one, is a relative extreme value, but it's also the absolute max on the interval. So when looking for absolute extremas, check all your relative extremas, but don't forget to check the endpoints. So again, this video is meant to be all kind of conceptual. I'll make a separate one for examples. Have a great day.